students, welcome in sgm-sp channel. Already from more days we started second chapter, mechanical properties of fluid, and by learning this chapter you can understand. Already you understood how much it is big. More points are there. From that session, if we can say, from that chapter only last one point is left. Today we are going to discuss the equation of continuity, and afterward I want to tell you only single point is left from that. It is Bernoulli's equation and their applications. In this lecture we are going to discuss the equation of a continuity, otherwise we can say the principle of continuity of the motion. ह्याचे दुसरे नाव असेल ते असे असू शकते, continuity of motion. Before to start that continuity equation, let me revise some part. Already we learned two types of flow. Fluid flows are there in that turbulent flow, and another one is there streamline flow. We know that streamline flow is very steady flow, and in that the all streamlines which are present, they are not intersect to each other, they are not cross to each other, they are parallel to each other, and they are parallel to the axis of a tube. From that tube they are going to flow. स्टेडी आपला स्ट्रीमलाइन फ्लो आहे तो स्टेडी फ्लो आहे, त्याच्यामध्ये असणाऱ्या सगळ्या स्ट्रीमलाइन एकमेकांना इंटरसेक्ट करत आहे, त्या पॅरलली करतात. सो फॉर द फाइंडिंग ऑफ द इक्वेशन ऑफ ए कंटिन्यूटी, हियर वी हॅव टू कन्सिडर अ स्ट्रीमलाइन फ्लूइड. We have to consider a steady flow of an incompressible fluid. Here we have to consider incompressible steady fluid. We know steady means it is a streamline flow, otherwise we can say it is a laminar flow. Here we know the property of that fluid. What is the property? The velocity of a fluid at a given point, it remains constant, but it is changes, it is varies from point to point. That means whenever the fluid is entering in this tube, okay, so what happens? Let me consider this point A. A is a point, otherwise I will consider that small cross section area here. Velocity at that point, here I consider here A point is present, here B point is present. At point A, whenever the fluid is passing through a given point, here I want to discuss the point A, the velocity of that fluid remains constant, but it is going to vary from point to point. That means from here velocity of that fluid is same, but at that place it is going to change. Okay, so this is a basic thing related to the our streamline fluid. Okay, now here consider a streamline, a steady flow of an incompressible fluid. Okay, here one of the tube is present, but by observing that tube we can understand the tube is varying in the diameter. We know the diameter of that tube is not a uniform, it is going to changes. If we can see here in this portion, here we can see its cross section area is higher. Let I will change little bit here. Okay, here the point B. We can see here diameter is different, here diameter is different, here diameter is different. That means that tube is not the uniform tube. Here whenever the fluid entering in that fluid, in that tube, whenever a fluid is entering in that tube, what happens? That tube flow, see there, that fluid is passing through all the cross section areas. Here is its cross section area is here different, cross section area is here different, here is also different cross section area. Whenever the fluid is entering in that tube, so from every cross section area the fluid is going to passes. That means here the cross section area is small, here the higher. That means there will be no change in the flow of the fluid. Okay, now we can see from the diagram. See here, point A is present here, point B is present here. I can show this way. Okay, here A, here the cross section area is section area at point A and cross section area at point B. Here that cross section area A1 is greater than cross section area A2. Here this cross section area is greater than that cross section area is A1. It is present at point A. Here the cross section area A2, it is present at point B. We can see the diagram of that tube by observing that tube. We can say the cross section area A1 at point A is greater than the cross section area A2 at point B. That we can understand. Now here V1 and V2. What is V1 and V2? See, V1 and V2 are the velocities of the fluid at point A and at point B respectively. So here V1 and V2 velocities of fluid at point A and B respectively. Here I want to tell you one thing. See there, any shape of tube is present there, and in that when the fluid is flowing in that tube, okay, that means in that tube the cross section area is going to change, the diameter is going to changes. It is not a uniform, everywhere the diameter is not the same. So how many streamlines are present in the entry? The same streamlines are present when the fluid is leaving the tube. Here I want to tell you another shape of that tube. Here suppose this type of shape is present there and fluid is passing from that tube. But in that tube, suppose three streamlines are present here. So here also we are getting three streamlines. Here in this way we are getting three streamlines. I want to tell you one thing, that streamlines, they are not cross to each other. Okay, they are not intersect to each other. Always they are parallel to each other. That means how the fluid is entering in the tube, similarly the fluid is leaving the tube. Here one thing I want to tell you, suppose here how much amount of fluid is entering in the tube, same amount of fluid is leaving the tube. That tube is not creating any fluid, otherwise it is not destroying any type of fluid. So again I want to tell you how much fluid is entering in the tube, same amount of fluid is leaving the tube. Suppose here we can say 10 liter tube is entering per second. At per second 10 liter fluid is entering in the tube. Similarly, whenever the fluid is coming out from the tube from other end, otherwise we can say similarly the fluid is leaving the tube, that time also here we will get the same amount of fluid, 10 liter per second. Okay, so at per second 10 liter fluid is entering the tube, but whenever fluid is coming out of the another end of the tube, whenever the fluid is leaving the tube, that time also we are getting the fluid 10 liter per second. It will not happen, here we will get 12 liter per second, here we will get 11 liter per second. It is not happen because in that tube fluid is not created and fluid is not destroyed. Same quantity of liquid flow at every cross section. Again, same quantity of liquid flow at every cross section. Here the diameter is small, here the diameter is maximum. As a cross section changes, means the fluid, there is no effect in amount of the fluid. So same quantity of a liquid flow at every cross section. Now see there, here let's move toward the next point. Here we can say some part of tube is narrow, otherwise it can say the shallow. Okay, this part is the narrow part of the tube, this part is wider in a space. Now what happened in this situation? See there, whenever the narrow part of when the fluid is flowing through the narrow part of the tube, that time the fluid will move fast. But when the fluid will flow from wider region, in that diameter is larger compared to this region, in this portion, in this part, what happened? It will get to more space. So the velocity slows down here. So I want to tell you, in less cross section area, the fluid moves faster compared to if the area is wider. In a wider cross section area, otherwise wider region is there. In that more space is present there. In that more space, from that more space, when the fluid is flowing, in this case, that fluid slows down. Its velocity will become less. But in this case, its velocity will become more. Now see that, let me take another point is the M. M is the mass of fluid. Just now we discussed how much amount of fluid is entering in the tube. Same amount of fluid is leaving the tube. So I want to tell you one thing. The fluid which is entering in the tube, it having the mass M. And the fluid which is leaving the tube, it having also mass M. Here we are going to use the conservation of the mass. What I want to tell you, see there, see some amount of fluid is entering in that tube, that same amount of fluid is leaving from that tube. So here mass of a fluid enter the tube. Mass, whatever fluid is entering, that fluid having the mass. So mass of a fluid entering the tube, then the mass of a fluid leaving the tube is the same. याचा अर्थ काय, ज्यावेळी फ्लूइड या ट्यूब मध्ये एंटर करणार आहे त्यावेळी त्याचं जेवढं मास असणार आहे तेवढंच मास त्याचं कॉन्स्टंट राहणार आहे. कधी, ज्यावेळेस ते फ्लूइड त्या ट्यूब मधून बाहेर येणार आहे. एंटर करताना जे फ्लूइड असेल तेवढाच अमाउंट मधलं फ्लूइड काय येणार आहे, ट्यूब लिव्ह करताना ट्यूब मधून बाहेर पडताना तेवढंच फ्लूइड असणार आहे. तो फ्लूइड कमी होणार नाही किंवा ते जास्त होणार नाही. म्हणजेच एंटर करताना जे फ्लूइड ट्यूब मध्ये एंट्री करणार आहे त्याचं जे मास आहे ते कॉन्स्टंटच राहतंय. जेव्हा कधी ते फ्लूइड त्या ट्यूब मधून बाहेर येणार आहे त्यावेळेस इट विल रिमेन्स सेम. ओके, दॅट मीन्स हियर ऑल्सो वी कॅन से द मास ऑफ ए फ्लूइड एंटर द क्रॉस सेक्शन एरिया A1 is equal to the mass of a fluid which enter through the cross section area A2. म्हणजे फ्लूइड ज्यावेळी इथे एंट्री करणार आहे त्यावेळी हा पॉइंट क्रॉस करून ज्यावेळी फ्लूइड पुढे जाईल त्यावेळी त्याचं जे मास असणार आहे तेवढंच मास ज्यावेळी तो हा पॉइंट क्रॉस करून पुढे जाईल तेवढंच मास राहणार आहे. शेवटी तो त्या ट्यूब मधून ज्यावेळी बाहेर येईल त्याही वेळेस त्याचं मास आहे ते कॉन्स्टंटच राहणार आहे. त्याच्यामध्ये कुठलाही फरक पडत नाही. आता आपण व्हेलॉसिटी बघितल्या काय होती, v1 be the velocity of the fluid which passes through the portion EF GH. म्हणजे हा पोर्शन ह्या पॉइंट मधून पास होताना फ्लूइडची जी वेलॉसिटी असणार आहे ती किती असणार आहे, v1. त्यासाठी लागणारा टाइम इंटरवल किती असेल, इन टाइम इंटरवल डेल्टा टी. आता इथे आपण त्या पद्धतीने जसे आपण वेलॉसिटी काढली तसं आपण मास काढू शकतो. द मास ऑफ ए फ्लूइड एंट्रिंग द ट्यूब थ्रू द क्रॉस सेक्शन एरिया. आता ज्यावेळी आपलं फ्लूइड आहे त्याला मास m आहे असं आपण सांगितलं. ते फ्लूइड ज्यावेळी इथे एंट्री करणार आहे त्या क्रॉस सेक्शन एरियामध्ये त्यावेळी त्याचं मास किती ते बघूया. हिअर पुढचा पॉइंट, मास ऑफ फ्लूइड entering in tube through the cross section through the क्रॉस सेक्शन A1 म्हणजे A1 या क्रॉस सेक्शन एरियाला पास करून ज्यावेळी तो येणार आहे त्यावेळी किती असणार क्रॉस सेक्शन ॲट पॉईंट A असं म्हणूया हे सोपं पडेल. ॲट पॉईंट A इज इक्वल टू किती असणार आहे ते रो हिअर A1 V1 डेल्टा T. ही जी किंमत आहे ही माससाठीची किंमत आहे कधी ज्यावेळी फ्लूइड आपल्या ट्यूबमध्ये एंटर करणार आहे ह्या पोर्शनमधून ते काय होणार पास होणार आहे त्यावेळीची किंमत आहे. त्याच पद्धतीने आपण V2 साठी किंमत काढूया. V2 बी द व्हेलॉसिटी ऑफ फ्लूइड which passes through here the portion is that cross section area PQRS in time interval delta T. Similarly, see that whenever the fluid is entering in that tube, we got the value of that mass. Similarly, we can get the value of a mass when the fluid is leaving the tube and when it passes through this cross section area PQRS. आता इथं आपण जी किंमत काढली ती कशाची काढली फ्लूइड ज्यावेळी ट्यूब मध्ये एंटर होतो आणि ह्या पोर्शन मधून ज्यावेळी तो पुढे जातोय त्यावेळी त्याचं असणारं जे मास आहे ते आपण आता काढलं. तसंच ते जे फ्लूइड आहे ट्यूब मधून बाहेर पडणार आहे मग ते ट्यूब मधून बाहेर पडताना ह्या क्रॉस सेक्शन एरियाला काय करणार आहे ते क्रॉस करून जाणार आहे ह्याच्या थ्रू जाणार आहे त्यावेळी असणार त्याचं काय बघूया आपण मास किती आहे ते बघूया. सी दॅट द मास ऑफ ए फ्लूइड here mass of fluid leaving tube through the cross section PQRS at point B, it is equal to rho A2 V2 into delta. So we are getting these two values. Now here we are using the law of conservation of mass, and also we know our this fluid is incompressible fluid. See that whenever incompressible fluid is flowing in a narrow section, that time that fluid will move fast. But if compressible fluid is present there, that time this compressible fluid will not move fast in that narrow region. Now here we are using that mass of a fluid entering the tube is equal to mass of a fluid leaving the tube. Here by using law of conservation of mass, here we can say mass of fluid entering tube is equal to mass of fluid leaving tube. So by putting this value, the values are with us here. Rho A1 V1 delta T is equal to rho A2 V2 delta T. That we are taking by the relation in between mass, density, area that already we learned in 11th standard. By simplifying that, here we will get A1 V1 is equal to A2 V2. If in that tube, just we are taking two different cross section areas. In that tube, if more cross section areas are there, it is going to also increases. A1 V1 is equal to A2 V2 is equal to A3 V3. So finally here we will get AV is equal to constant. Otherwise, we can say the area is inversely proportional to the velocity. Okay, here as the velocity depends on any fluid is when passing through the tube, that time the velocity of that fluid is depends on the area of that tube. Here we see if the area is narrow, it is a shallow, that time the velocity of that fluid is more. And if the area is larger, wider space is there, in this case that fluid which is passing through that wider region, it slows down, its speed is not that much more as like the narrow region. Okay, here we are getting one another relation is there in such a way that here dv by dt. Otherwise, if we are going to draw graph, that graph will shows here the relation in between velocity and area. Here is velocity, here is the area. We can understand as the velocity increases, the area is decreases, and as the area increases, the velocity is going to decreases. Here we can say for that equation AV is equal to dV by dt. Here we can say that dV by dt means what? It is the volume of a fluid per unit time passing any cross section area of the tube. dV by dt means volume of a fluid per unit time passing through any cross section area of the tube of flow. It is called as the volume flow. And if we are rearranging that term, here we will get if that only rho into dV by dt, that we will get dm by dt. It is mass flux. Here we can say it is a volume flux, and last equation it is called as the mass flux. Here AV is equal to constant. If we can say it is first equation and it is second equation. So that equation number second is the equation of a continuity. आता ह्याच्यामध्ये जे सेकंड इक्वेशन आहे त्यालाच आपण काय म्हणणार आहे, इट इज अ इक्वेशन ऑफ ए कंटिन्युटी. आता ह्याचं जर एक्झाम्पल सांगायचं झालं किंवा ह्या इक्वेशनवरून आपल्याला कुठल्या कुठल्या गोष्टी मिळतात हे जर सांगायचं झालं, दिस इक्वेशन इज फॉर द स्टेडी इनकम्प्रेसेबल अँड नॉन विस्कस फ्लूइड. सेकंड पॉईंट जर आपण इक्वेशन सेकंड वरून सांगायचं झालं तर तो असा असेल, द व्हेलॉसिटी ऑफ ए फ्लूइड इज इंडिपेंडेंट ऑफ द लिक्विड. नेक्स्ट पॉईंट इज देयर, as the velocity of flow will be increases, the area is going to decreases and vice versa. ज्या ठिकाणी क्रॉस सेक्शन एरिया हा जास्त असणार आहे त्या ठिकाणी व्हेलॉसिटीची किंमत ही कमी असणार आहे. ज्या ठिकाणी क्रॉस सेक्शन एरिया हा नॅरो असेल, शालो असेल, कमी असेल त्या ठिकाणी व्हेलॉसिटी ही काय असणार आहे, मॅक्सिमम असणार. आणखीन एक एक्झाम्पल सांगायचं झालं डे टू डे लाईफमधलं रिव्हरच्या बाबतीत जर आपण बोलायचं झालं, व्हेनेवर रिव्हर फ्लोज फ्रॉम द हिली रिजन, ज्यावेळी डोंगरांमधून टेकड्यांमधून ज्यावेळी नदी खाली वाहते येत असते त्यावेळी तिचा असणारा जो आपण काय म्हणतो त्याला व्हॉट एव्हर द करंट फ्लो ऑफ दॅट रिव्हर, तिचा जो फ्लो असतो तो कमी असतो, तिला मिळणारा जो क्रॉस सेक्शन एरिया आहे तो कमी असतो. पण त्यावेळी ती येताना वरून खाली ज्यावेळी धावत पडत असते खाली त्यावेळी तिचा क्रॉस सेक्शन एरिया जरी जास्त कमी असला तरी त्याचा स्पीड हा जास्त असतो. तीच रिव्हर ज्यावेळी प्लेन सरफेसवरती येते, पठारावरती वाहत वगैरे असते त्यावेळी तिथं ती आपल्याला दिसताना संथ गतीने वाहताना दिसते, कारण त्यावेळी तिचं जे पात्र असतं ते पात्र खूप मोठं असते, त्यामुळे तिथं तिचा स्पीड आहे तो कमी होतो. आणखी त्याच बाबतीत एक उदाहरण सांगायचं झालं तर खोल नदीमधला जो भाग जास्त खोल आहे तिथं पाण्याचा वेग आहे हा मंदावलेला असतो, त्याच्यापेक्षा जो भाग कमी खोल आहे आपण ज्याला शालो रिजन, अदरवाईज आपण त्याला नॅरो रिजन असं म्हणणार आहे, त्या ठिकाणी नदीच्या प्रवाहाचा वेग हा जास्त असतो. So these are the example of the equation of a continuity. It will ask for the state board 4 marks. So in such way you have to write the equation of a continuity. It is very important. In next exam we are taking the exam. For that exam the syllabus is up to the equation of a continuity. Here graph is given, some extra points are out of the syllabus. These all points are from the NCERT JEE NEET. You can note down this. I hope you understood this lecture. Thank you.